Alright guys, we have this circuit and we have to calculate the current in the 132 ohms resistor and the potential difference across the 20 ohms resistor by using Kirchoffs laws. Alright, we want to find the current in this 132 ohms resistor and the potential difference across this 20 ohms resistor. Alright, now what do? We have to understand first that this is loop 1 and then this is loop 2. Alright, because this is a closed loop. This is another closed loop. Now another thing is we're going to make an assumption that I1 is the current flowing through here and make an assumption that I2 is the current which flows through this. Alright, make an assumption that I1 flows here and I2 flows here. Alright, now so we're going to apply Kirchoffs law. That's Kirchhoffs voltage law that says the sum of potential difference in a closed loop is equal to 0. Alright, so applying KVL, that's Kirchhoffs voltage law, that says summation of potential difference of voltage equals 0. We're going to have this to become, now for this first loop, we are moving from this battery, we are moving from positive to negative, from negative to positive. Alright, so it's going to be plus what? 200. So I say from loop 1, I'm going to have what? 200, all right, and it's going to be positive. Now, there's going to be a voltage drop on this 20 ohms resistor, all right, and the current flowing through this is I1, so it's simply going to be what? Minus 20 I1, all right. Now, coming down here to this resistor, now this 132 ohms resistor is between loop 1 and loop 2. Alright, it is between loop 1 and loop 2. So the current that will be flowing through here, of course there's a voltage drop, so it's going to be minus 132 into bracket. The current that will be flowing through here now will be I1 minus I2 because we assume there's a higher potential here than here. Alright, so it's going to be the difference between this and this. So it's going to be I1 minus I2. Another reason is because this 132 ohms resistor here is between loop 1 and loop 2. But now that we are taking our current flow from loop 1, the current that's going to be flowing through this is going to be I1 minus I2. Alright? Now let's continue. So we don't have anything again. So it's going to be equal to what? 0. Alright? And then we're going to have what? 200, alright, minus 20 I1. Now, minus 132 multiplied by this gives us minus 132 I1. Alright, this times this gives us what? Plus what? 132 I2 equals what? 0. Now, this becomes what? 200 minus 20 minus 132 gives us minus 152 what? I1 plus 132 I2 is equal to 0. Alright? Now, what we're going to do is, let's take minus 152 I1 here, so it becomes positive, and take this here and equate it to 0. So rearranging this equation, it becomes what? 152 I1, alright, minus 132 I2 equals what? Equals 200. Alright, the 200 here. Alright, so now we have this. Now, if you check very well, 4 is a common factor between 152, 132, and 200. So I'm going to divide through by 4. So I can reduce it, alright? Divide through by 4. Alright, divide through by 4. So when we divide through by 4, we have 152 divided by 4 gives us what? 152 divided by 4 gives us what? 38. So it becomes 38 I1 minus 132 divided by 4 gives us what? 33 what? I2 equals what? 200. Sorry, 200 divided by 4 also gives us what? 50. So this is equation 1. Alright, that's equation 1. Now, from loop 2 now, we're going to go to loop 2. From loop 2, let's analyze from loop 2. Now, this is loop 2, right? Now, we assume a current flow like this in the clockwise direction, which is I2. So now, coming like this, now current is going to flow through the 132 ohms, all right, resistor. But the thing is, it is between the I1 and the I2. That is, it's between the loop 1 and loop 2. All right, it's between loop 1 and loop 2. But this time, the current flowing through here will be I2 minus I1 now. All right, not I1 minus I2. It's going to be I2 minus I1. So of course there's a voltage drop on it too. So it's going to be minus 132 into bracket I2 minus I1. All right. Now moving down here, there's also going to be a voltage drop on this 60 ohms resistor. So and the current flowing through is I2. So this is going to become what? Minus 60 what? I2. All right. Now the next one is what? The 100 volts. This is from positive to negative, from negative to positive. So it's going to be what? Positive 100, all equal to what? 0. All right. Now let's simplify this. So this is going to be minus 132 multiplied by this gives us minus 132 I2. This multiplied by this gives us plus 132 what? I1 minus 60 I2 plus what? 100 is equal to 0. All right, let's continue. This is going to be 132 I1 minus 132 minus 60 gives us what? Minus what? Minus 132 minus 60, that gives us minus 192. All right, minus 192. All right, minus 192 I2. All right, now we can take this 100 to this side and it becomes minus 100. All right, and it becomes minus 100. Now of course if we look at this equation, they have a common factor 4. If you look at this equation, they have a common factor 4. So we can divide through by 4. So this is going to be 132 divided by 4 gives us what? 33. 192 divided by 4 gives us what? 48. All right. So this becomes what? 33 I1 minus 48 I2 is equal to 100 divided by 4 gives us what? Minus 25. So this is equation 2. So therefore you have what? 38 I1 minus 33 I2 equals 50, equation 1. And then you have 33 I1 minus 48 I2 is equal to minus 25, which is equation 2. Now you now have two equations here. Now you can solve these equations by using Cramer's rule, that's the matrix method, or using substitution method. Now when you solve these two simultaneous equations, you are going to get your I1, all right, you're going to get your I1 to be equal to 4.37 ampere, and then you're going to get your I2 to be what? 3.52 ampere. All right. Now we've gotten the I1 and I2, all right, solving that simultaneous equation. Now the next thing for us to do is find the solution to the question we are being asked here. Calculate the current in a 132 ohms resistor. Now how do we do that? Now there's a current flow moving like this, and let's assume it is I1. Now there's a battery here too, so let's assume there's a current flow moving this direction, which is what? I2. All right, and then let's assume that the current flowing through this 132 ohms resistor is I3. All right, it's I3. Now do not forget Kirchoffs current law. It says that the sum of current entering a junction is equal to the sum of current leaving. Now I1 and I2 are entering this junction. I1 is entering here, I2 is entering here, while I3 is leaving. All right, so the sum of current entering is equal to the sum of current leaving. Meaning that what? That actually implies that what? I3 is equal to I1, sorry, plus I2. Meaning that the current flowing through this 132 ohms resistor is I1 plus I2. All right. So what is that going to be? So I3 is simply going to be I3, which is the current flowing through this 132 ohms resistor. Now is going to be equal to what? I3 is going to be equal to 4.37 plus 3.52. So I3 is going to be equal to what? I3 is going to be equal to what? 7.89 ampere. All right, 7.89 ampere. So that's the current that is flowing through the 132 ohms resistor. Now the next thing we want to do is to calculate the potential difference across the 20 ohms resistor. Potential difference across the 20 ohms resistor. Now, the current flowing through the 20 ohms resistor is I1. All right, the current flowing through the 20 ohms resistor is I1. So for us to get the potential difference, now it takes current and resistance to give us what? Voltage. All right, so the voltage, all right, the voltage flowing through the 20 ohms resistor, which is potential difference, all right, is going to be what? So V, that's for the 20 ohms resistor, is going to be equal to what? I1 multiplied by what? 20 ohms, all right, which is the resistance of the resistor. So this becomes that V 20 ohms is equal to I1 is given to us as what? 4.37 multiplied by what? 20. And this is going to be equal to what? 87.4 87.4 volts, all right, 87.4 volts. So this is going to be the value of the voltage flowing through the potential difference flowing through the across the 20 ohms resistor, and then this is going to be the current, all right, flowing through the 132 ohms resistor. Now that will be all for this video. Now do not forget to like this video, share this video, and hit the subscribe button. After you hit the subscribe button, hit the notification button, all right. Feel free to ask any question in the comment section, and do not forget, Jesus loves you. Thank you.